All right, so this is fall 22. This is take home test 2B part 1. And here we go. You all, let me get so I can see you guys and I can see the chat. That was weird. I mean, I was at the right address and I had the right passcode. I mean, everything. I don't know why it wouldn't. Technology, huh? Okay, I got the chat open now. Hello, everybody. And you can either through the chat or through audio. All right, here we go. Number 1. This is I went around the room and saw that most of you were starting, and I apologize that it's such a tight little space. You can't blow it up like I can. So rather than spend 15 minutes slowly going through it all, I'm going to cut to the chase because we've done this a few times. So there is my answer to, hold on, let me just blow it up. Okay. And if you look closely, you can see my heights each time. Take a minute, compare them to yours. Don't expect to have the exact same numbers. I have the benefit of blowing things up, so I'm going to take a screenshot of who all is here. And I can't offer stamps because some kids have to work and it's not fair, or they got some kind of sporting event or something. So, but it's always good to know who my people are. All right, so I'm just looking at Stegosaurus tail, and promise we'll do a negative trio in part 2, which you'll get tomorrow. That's available, by the way. Oh no, it isn't. I can make, if I remember it or not, I'll make it available. I'm sure you have your hands full of part 1. Okay, so there is my steps. These are my values. I'll just blow that up. There's my values. And then there's my steps, my orange steps. I collapsed each step, as we know. We've done this a bunch of times now. I collapsed each step down to a dot at the center. That's where tangent equals secant. That's where instantaneous equals average. And I found the slope. It looks like it rises 44 meters per second every 5 seconds. And so I got a 8.8 is my slope. Swago says, why'd you start at 0, 0? You mean from my velocity? Oh, here? Oh, why wouldn't I? Oh. Well, you know what? Haha. You may have a point there. Okay, look. Shargo's asking, it appears that I started at 0, 0, but that thing is so tiny, you know, I can make the case that, well, I'm close enough to 5. Although he has a good point, because I'm saying I'm at 5. Yeah, see, my gig is up because I'm at 5 at 1 second, where I should be at 1 second, I should be at 9. All right, well, I give you that. It's a little bit, that's a little bit off. It's not going to affect my steps, but I'm going to give you a stamp for 2 stamps for pointing that out. Yeah. And then for velocity, I started 0, 0. There's no reason not to. I didn't say there's a V0. I won't do that. I wouldn't tell you a V0 on the test. That'd be kind of cruel. I mean, because then you wouldn't start it. You wouldn't start your steps at 0, 0. But I'll give you that. All right. So this is the same data, right? Yeah. Okay. That was just a weird start for me. Anyway, so I got an acceleration of about 8.8. Anybody else get around 9-ish? You should get around 9, 8.5. I'll take between 8.5 and 9.5. for accelerate meters per second squared. Okay. Ready to go on, or you want to talk about it? The thumbs up if you want to go on. Okay, 2 people want to go on, 3. And I'm recording this, so you can always go back and pause it if you want. Okay. All right. Who all do we have here? We got Myra, we got Owen, we got Matt, Megan, Chris is here. Shargo, Owen's here. Elizabeth's here. Mandy. Trace, Ryan's here. Finn's here. Kaylee's here. Rafo's here, and Adam. Oh, okay. Good crew, good crew. Let's keep going. Number 2. 2 is I'm going to do the same thing I did last time, where I show the blank and then I show the finished product. But on this one, it was a little strange. I saw some of you kind of questioning it. Here, you're starting from the top and working your way down. Okay, so I got a new tip coming in tomorrow. This one's messed up. So you're working your way down. You're doing slopes. And so first thing I did was, I'm just going to slop it up here. Then I'll show you the nice finished product. But I found this, really black. I found this slope here for that right side up. Then I found this slope here for that one. I plotted the slopes down here. This one's somewhere up in, I don't know. So I'm slopping it right now, somewhere like up in there. This one's down in here somewhere because it's negative. And then I showed the boundaries, and so the equation. Now, I did notice that some people were putting the equation for this. If you can see that arrow, yeah, for this. No, down here, because to go from for integrals, is I start down here and I work my way up here. I know it's kind of weird, and I wouldn't do that to you on a test cold, because it's kind of weird, because you're starting here, you're doing the slope, and then from the slope you're coming up with the integrals. That's okay, but that's not the way we did it in class. We were going the other way. So that's of course a DT and a DT. Get those easy low-hanging fruit. And this guy starts at 0 and goes to 10, and you have to put hours. Okay, you got to put at least the unit on one of them. And then it goes from 10, I always put on the big one, to 15 hours. And then I'm going to have whatever my slope is goes there, and my negative slope goes there. So let's just cut to the chase. So here's what I got in a previous year when I did this. I got 2 miles per hour on the first slope and -1 miles per hour on the second slope. Okay, good. Keep going. Yeah, all right. Well, one person. Shagar says he's ready to go. Okay. Finn says okay. Finn's always ready to go. All right, now we get to 3. It says sketch the following situations on the V versus T graph. This one's weird. Okay, we need to take a minute on this one. For the V versus T graph, with a solid line, acceleration is negative. Okay, that means that you're going to have, that means when I say acceleration is negative, that means that I have a negative slope. Okay, so I know, I'll make it blue for this first part. I know that it says solid. Okay, so the solid blue is going to look like that because acceleration is negative, but I'm speeding up. So if I did this, that would be wrong, because acceleration is negative, but I'm slowing down. See, I'm getting closer to 0, and that's not true. So no, I have to have a negative slope and be speeding up. So it has to look like it could start here, it has to be in the 4th quadrant. Okay, there's none of this can be in the 1st quadrant. So it has to, something like that. You can start at 0 if you want, but something like that. Okay, you can start at 0, but here my speed, my velocity is becoming more and more negative, but it's speeding up. See, I'm just going backwards. Like I have in reverse, and then I'm flooring it, so I'm going backwards. Okay, if that makes sense. with a dashed line, show acceleration is positive. So I'll go green. Dashed line, of course, positive slope looks like that. So I know my dashed line is going to be in that, but I'm slowing down. So I can't put it here because that would mean I'm speeding up. So I have to, so it's weird. I got to put it down here. So I want to just show you, see, here's the thing that this, it looks supposed to be straight. That's supposed to be a straight line. I guess it doesn't have to be, didn't say, well, it says line. Okay. So that your dash line, so it has to look something like that. But I'm trying to get out of your lexicon the word deceleration, because deceleration is it's not a good physics word, because I'm either negatively accelerating or positively accelerating. I could be negative acceleration and speeding up, as I'm showing here. You see what I'm saying? But deceleration doesn't make sense. Where would that go? Okay, so that's the point to this problem. Here's my key from a previous year. I'm all over the place, but same idea. Oh, and by the way, I'm glad I saw that, because some people on a test, they do this. And boom, now they lost. But if this is worth 20 points, they just lost 5. Because no, you can't put anything in the first quadrant. Okay. So take that out, because then it would be speeding up and it has to be slowing down the whole time. Okay. Keep moving. I guess we can. I feel like I'm having to catch up here. All right. So let's at least start this one, and then we'll go right. Then we'll jump to the key. We'll get this set up. Ludicrous mode. And I'm looking at, there's my acceleration. There's my time. I haven't looked at this in a couple of years. Maybe this is last year. I don't remember. How many yards? Okay, so I'm trying to find delta X. Will it have moved? And this requires second orange, which we know. So right there, if I read that, I'm going to go to the, I need a little quick drawing here. Looks like I'm starting here. And the drawings early on in the year are fairly easy. They're simple. I know, I don't need to write the numbers down, but I know A, I know T, and I'm trying to find delta X. And that's good enough for this simple drawing. Okay, then it says that you'll need second orange. So we have delta X equals V naught T plus 1/2 AT squared. Okay, well, I have to assume that it started at 0. It says standing start. Okay, standing start. So I know that V naught is 0. That goes away. So I just have 1/2 AT squared. Fine. Now, we've done problems like this, actually. So 1/2 AT squared. Okay. So in my boxes, I got a 1/2. I got an A, and I got a T squared. Okay, nobody's asked a question here, so I guess we're doing good. You can either ask it or you can type it. Maybe on those chats, maybe I should take a screenshot of that before we leave and put that in the comments or something, if it's, I don't know, if it's pertinent. All right, so now I come down here, I put the 1/2, and now this is, gotta be careful on this. I got 571 meters per minute per second, but I put that minute and second together. I showed you this before. Minute dot seconds, that's legal. You put your time, like meters per second squared. You put your 2 times together. And then my T squared is 4. That's on top, 4.0. So this one's actually easier than the last test. I got to square it, and it's over 1 squared, which is 1, doesn't matter. So that's 16. Okay. Looks like those are my givens. Everything else is conversions. Okay. So questions? You want to go right to the answer? All right, here we go. The answer is about 83 yards. Looks like a little over 83 yards. I had 3 conversions. This is about as straightforward. I'm not going to promise that the one on the test is this straightforward. Okay. Now, this is not like a practice test where the test has to look very, very, very similar. It'll have a unit. I think it'll have a unit analysis. I probably has a unit analysis in it. I haven't written the test yet, but I'm not going to say. In fact, I'll say right now, it's probably harder than this. Yeah. Sugar said, well, can I write it 4 squared? Yeah, you can just write it. Yeah, you can say 4 seconds times 4 seconds, certainly. It doesn't matter. All right, everybody else get around 83. We're good. Keep going. Yes, of course, Finn's always got it. Finn has his finger on the thumbs up button at all times. He said, let's get the show on the road. All right. Uh-oh, well, there's no, I mean, we can go through all this, but I don't want to spend the next 20 minutes going through something that's just in your notes. Let me just point out a couple of things, okay? Each on the test, I don't remember how much, it's probably worth at least, I bet this is worth 50 points. So here's where you get your 50 points. You have you get a point for the X or V or A, whatever it is. You get a point for the units, so meters, and you'd be surprised. People will say X, and then they'll all of a sudden call X meters per second squared. You know better than that, but they'll do it because they get their pattern all mixed up in their head. If this is what happens if you don't practice this, if you don't write this out a few times, so that, because I'm telling you, it's going to be on there. So you've been warned. So you get a point for the units, and that's an easy point over there. T, you can put seconds if you want. You get a point for the curve. We know that's a parabola. This is linear. This is flat. Okay. You get a point for knowing the order. Well, this is always 0. All these across the bottom are 0. And then it always goes 1, 2, that'd be 3, 1, 2, 3, you know, goes up. That should be easy points there. And then you get a point for the equation. And so we've already seen these equations, but I'm just telling you, that's how we're going to do it. So you would say A equals A. I'll do this one, then we'll show you the whole thing. So A equals A naught. V or V final is the first orange equals V naught plus AT. I'm doing it in blue, but that's weird. And then this is the second orange. You guys notice that? This is it's the graphical version of the second orange. X equals, which by the way, I finally got put up. Owen did that. So if you're working on that one, Owen already beat you to it. X naught plus V naught T plus 1/2 AT squared. If you just say 1/2 AT squared, I'll say fine. If you, in fact, no, you can't say KT squared here because we now know it's 1/2 AT squared. Okay, let's go right to my answer here. A little bit messy. Looks like we had a discussion on quintets, but I'll erase that part. Let me erase this. Okay, I'll give you a minute to look that over. I'm showing trends there, you know, the diagonal. It's not like you're trying to memorize 50 things because you can just use the pattern. It's like counting to 100. You don't have to memorize. Oh, wait, 27 comes after 26. How am I going to remember that? It's the same pattern. It's the same pattern over and over and over again. Oh, it looks like I also answered number 6. Let's look at number 6. Which of the following, let's go back and talk about it. Number 6 is which of the following velocity versus time equations correctly describes a ball rolling down an inclined plane? So you'll have a question kind of like this, as if I recall, and this is fine, except that that's not that. I mean, I'm not saying that could be a true statement, but it doesn't describe this A. It doesn't describe a ball rolling because that says velocity is constant. Okay, that's like the finger dance or, you know, a duet. This is not a duet, it's a trio. So we get to B. Well, B looks good. What's wrong with B? It has a T in it. It's the equation for a line. V equals 7T. That's a line, and velocity is linear. So why isn't that correct? Stamp, who can answer that question? Why isn't B correct? Units, thank you, Ruffo. So that is units is the problem. I can't, 7 meters per second times seconds gives me 7 meters, so the units don't work. All right, and therefore C finally, like Goldilocks, that is finally just right. Let's double check though. No, that would be a quartet, so D can't be it. That'd be a quartet. E can't be it. So it has to be C. Okay, let's keep going. Now we get to 7 and 8 are the combo here. Notice that on 7 I gave you 2 wrong answers. I used to do this a lot. I thought I was being clever. It's like for I don't give many multiple choice questions, but if it's a quantitative multiple choice question, I would work it with 1 mistake. Okay, so here's what I used to do. Here, on multiple choice questions, I used to like I'd work the problem wrong and make that one of the answers. I thought I was being so clever, but that's the worst thing you could do as a teacher is to because then the kid sees, oh, they see their number, they're all right, they got it right, they think they're right for like 2 weeks until they get their test back. So you're asking for misconceptions. So now what I do on numerical problems is I'll work it correctly and then I'll just make up 4 other answers. So if you're not getting an answer, if you're getting an answer that's not one of the, you're doing it wrong, at least you're doing it wrong. Unless you're extremely unlucky. So I thought, well, I'll give them a couple of, like, I'll work it, I'll make a common mistake and then I'll show, that's called they're like 1 mistake answers, like you're close, but you made some mistake. And I kind of stopped doing that because it just confuses kids. So I don't really do it anymore. All right. That's what you call being too clever. So we have K when acceleration is changing linearly with time. Well, if acceleration is changing linearly with time, I have a quartet, right? Because that's a quartet. They're accelerating, so I must be in a quartet situation. So I come back here, it says K is that K, and now look at K and realize it's units of jerk. That's units of jerk. When acceleration is changing linearly with time, I promise you, I'm not going to do a whole lot of quartet stuff because we really haven't done much pink. I mean, quartet is pink, and we're trying to focus on trios. So I might have 1 question on the test involving a quartet, something like this. Okay, that's it. I promise you, Scout's honor. If there's more than 1, you can come after me. When acceleration is changing linearly with time, how far will the object move between the 3rd and 7th second? Okay, so this is a good question. I would expect to see this on the test, certainly. We're thinking, how far is it going to move? So we're trying to find X. Well, it's in a quartet, X equals KT cubed. Now we said in class that K was like 1/6 jerk, but don't worry about that. We'll just call it K. Okay, so because we're really not, that's more packet 3 stuff. So X equals 4.2 meters per second cubed times T cubed. And so we plug in, first you plug in, so I'm going to do X of 7. And then so I plug in 7 cubed, 7 seconds cubed. Okay. And then I'm going to plug in X of what? 3. And I go once again 4.2 meters. I know people miss this problem all the time on tests, this kind of problems. Times 3 cubed. Okay. And I promise you, well, I can't promise you. I'm pretty sure I'm going to put this on there. If there's room, I'll put this on there. I got a lot of graph stuff, try and squeeze in, So I'm thinking I'll have this, but okay. Because we got a whole nother take-home test, and I got to take 4 pages and squeeze them down to 2. So it's going to I got to drop some stuff, obviously. So you punch that in, and now it's a bunch of number crunching. You punch in, and you get, dun, dun, dun. Oh, what a mess. Looks like I got, I never answered it. Okay. Oh, I did. 1328 is what I get. 13 1328, 1327, 1328. Okay, fine. And that just has ABC. There's actually a D and E that got cut off or something. Okay, on my key anyway. All right, so 1327, you know, I stopped putting none of the above because a kid will get 1327 and say none of the above. Okay, just round off here and there. All right, 1327. But then it says sketch this function. So we know it's cubic, and I'm going to assume it starts at 0. So it's a cube. Cubes look a lot like parabolas, but I'll go dot, 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 dot. Okay. So I'm supposed to sketch it between this 3rd and 7th. So I go 3 seconds is here, 7 seconds is here, and then 3 comes over here, and 7 comes over here. And the difference is, okay, am I going to have to really do it? Oh, good grief. Let's see if I got it here. I got it here. Where did I get? Here we go. So it's something like this, but then, oh, shoot. You're supposed to put numbers in. 1441. This is 1441. And this is 113. Just to look, I mean, look at 3 seconds. That's the crazy thing about jerk. At 3 seconds, you're at 113, what is it, meters, 113 meters away. But then 4 seconds later, bam, you're at 1,400 meters away, 14 football fields. You were 1 football field away. Now you're 14 football fields away, 4 seconds. That's why you just can't maintain that kind of thrust for very long. You need like massive rockets, like on, you know, on the Falcon 9 or something. You need some big, huge Saturn V. You need big, huge rockets to maintain, you know, a good amount, a minute's worth of thrust, which gives you a quartet jerk. Okay, keep going. Yeah, where's my fin at? Fin left. Fin. Oh no. Okay, fin's still there. All right. Go on it. All right, number 9. Yeah, number 9. Oh, here we go again. Another one of these guys. It says now it looks like once again we're dealing with the quartet. When velocities change, now that I had 2 of these on here, so obviously there's going to be at least 1 on the test. Velocity is changing parabolically with time, so that kind of gives us a hint there. We know that it is a quartet. Can't wait for this new tip to get in. This is driving me crazy. How far will the object move? So once again, it's the same kind of problem. X versus t, we got a cube again, blah, blah, blah. And we have x equals 5. I don't know why I put the same problem basically twice, but okay. I'm pulling problems from old tests and I stick it in there. T cubed. And it says how far is it going between the 4th and 8th second? So same thing. You plug in 8, you plug in 4, and you subtract the 2. So 5 times, and I'll go right to the answer. 8 cubed and 5 times 4 cubed. Okay, and you punch in, you get 2240. 2240. Okay, that I mean that. Okay, so oh my goodness, if k is 5, this is a side note here. If k is 5, didn't we say that k was equal to 1/6 of jerk? I mean, that makes 1/6 of j is 5. That makes jerk 30. Jerk being 30, no one's going to survive that. That's crazy. 30 meters per second cubed. That is crazy. Yeah. So, I'm looking at an extreme case here. Rocket, big rocket. All right, keep going. Number 9. Number 10. 10. For the position versus time relationship. So we're kind of looking up there at the tree, at the beautiful patterns, okay? For position versus time relationship, which one of the following graphs would illustrate a car accelerating uniformly. Okay, right there's the key. Accelerating uniformly means that A equals a constant, so A equals A naught. It's accelerating uniformly means constant, means it's continuously. The acceleration is not changing uniformly, it is just accelerating uniformly. Okay, so now we know we're looking at a trio here. I should make it orange. Trio. Okay. Just from reading that, from rest to 30 miles per hour, and which one of the following graphs? Okay, so we have a positive zero order. Well, that's not it. I mean, zero order, that's like a solo. Positive first order, and we're supposed to show position versus time. So X versus T in a trio, we know looks like this, right? It's a parabola. Okay. If you didn't know that, you need to go back and look over your beautiful patterns a little more closely. So that's not a first order. No, first order means like X equals T. Okay, some KT. Negative, no, it's not negative. Positive second order, that's it. Let's double check number 8. Third order, no, that'd be a quartet. So it's a positive second order is a trio. Okay, these are the kind of multiple choice questions you have in physics. Number 11. Here we go again with this crazy thing of volleyball and negative acceleration and all that business. So my suggestion on this one is to plot it, is to sketch it. So if a volleyball has a negative velocity, so if this is V versus T, so a negative velocity puts me in the 4th quadrant. So I'm down here somewhere. I already know that from that part of the equation. And a negative acceleration. Well, negative velocity in the 4th quadrant. Negative acceleration means my slope looks like this. So we're back to this thing, same thing again. My slope looks like that because that's a negative. It's a negative acceleration, negative slope. Then the speed of the ball must be increasing. The speed is absolute value of velocity. So it's getting faster and faster in the negative direction. So in the volleyball court, someone said, okay, this is my origin. Anything moving to the left of it is negative. Anything moving to the right of it's positive. Like the net was the origin. So this ball was moving, was accelerating to the left. So that graph would look like this. Okay, think about it. 12, which of the following graphs is associated with this is totally different problem now. Which of the following graphs is associated with the velocity changing parabolically with time? So for velocity changing, so as you're going back, and that's how important beautiful patterns are. You can't, because you can use that as a template to answer a lot of questions afterwards. So now V versus T is doing this. V, not X, V versus T. So I must be in a quartet situation because the velocity is parabolic, X is cubic, right? So what am I doing here? Which of the following graphs associated with velocity changing parabolic with time? Oh, so in other words, I'm asking for the family. What family are we in? First order jerk? No, because first order jerk is a quintet. I promise not to ask any quintet questions. 4th order position? No, that's a quintet. First order acceleration? Oh, so acceleration, A versus T, good grief, this tip would look like that. That is first order. So I like C. Let's double check. D, 3rd order jerk. Good grief, that's like a pop or something crazy. 2nd order position, no, that's a trio. So there you go. So it has to be POE, process of elimination, has to be C. Okay, no comments, nothing. Okay. Let's finish this up. That's how I did it a couple of years ago, or was it last year? That was my explanation. Okay, fine. Last one. Oh, oops. Last one. 13. Okay. Which of the following is this last one? Which of the following is, and we're gonna make it by 9:30. Can't believe it. Which of the following is the correct equation for velocity versus time in a quartet? This one's kind of challenging because Okay, we're dealing with a quartet, and it's velocity versus time. So we know it's second order, right? Because three, like I was showing, 3, 2, 1, 0, jerk for a quartet. That's jerk, acceleration, velocity, position. Okay. And so we're dealing with a velocity versus time in a quartet, so it's second order. So V versus T is going to look something along these lines, something like that. Well, that's not it. A is constant. No, that's a duet. B, no, it's not linear. C looks right. Hold on, because it's squared, right? Squared. D is no, D's not right. E, no, that's some kind of crazy. That's way big. That's a quintet. And F, so it's down to E, C or F. C or F. Now, who wants to answer that? Who wants to type in which one's correct, C or F? They both look, at first glance, they both look right. Uh-oh, I see some things wrong with C. What do you think? Okay, Rafael says F, Ryan says F, Megan says F. I don't know, they're pretty smart. So that right there is a problem, right? V equals V naught T. Units are really powerful way of checking whether an equation's right or not. That's just impossible. You can't do that. So I'm leaning towards F. And that would be F. And so before we go, I want to point one thing out. The second orange looks like this. X equals, now hold on, stay with me here. Let's say, let's do it the way it is written here. V naught T, plus 1/2 a T squared plus X naught. I'm just writing it in the order that it's written here. And then if I go, remember diagonally, the pattern. So if I'm doing a pink, which these are pink equations, the quartet. So if I'm doing pink, done. Okay, if I'm doing pink, then I would have V, and the equation's the same, except that all the variables have moved down one. So that would be A naught T plus 1/2 J, not J naught, because J is constant, T squared plus V naught. There it is. So my point here on this problem is, A, you can figure it out, this process of elimination, but to show you that's why it is the case, because of the diagonal, okay? Because of the pattern. And no jerk in C, and right. And so you're not, this should have been, for C, this should have been jerk, right? They can't be acceleration. The units don't work again. So there's a lot of things wrong with C. It looked right at first glance. All right, so that's a pretty tough question. That would be like maybe even on an AP test. So that's a pretty good question there. All right, who's got any questions before we go? All right, it's 9:30, 9:31. You guys are free to go. I will stick around and answer questions. I'll keep the recording on for now, but everybody else can go. You should be able to get your 4 stamps tomorrow by filling in the back. Shargo had a question though. We're in overtime now. Shargo had a question and said, could you go back to number 1 again? Number 1. Okay, number 1. We are on number 1 again. And Shargo's going to keep, he's going to keep hitting home on that. You know, he's like a good lawyer. He's going to keep hitting home on this 0-0 thing, you know. I don't have an explanation. I thought I'd get away with making you think that it was 5 was close, but then it says 1-9, and I blew it because that should be. Oh, well, okay, hold on. Look, if 0 is 5 and 1 is 9, then that, okay, that'd be 4. That would be 4. Okay, I'll give you that. That's 4. I think we're okay. I hope after that, please tell me. How did you get the heights? Oh, that's a good question. Yeah. Yeah. I will take, that's a very good question. Look what I did. See, but Shargo, there's no way, Shargo, you can do that. I took this guy, this scale, and because between 100, so I would move this, because I could blow things up, I would move this scale around. And because I had to be the key, so I just moved this scale, whereas you do not have that benefit. Because the key can't be slopped. I mean, the key's got to be accurate. So that's where I get like that being 80. See, if I put that there, that's right at 80, that height. If I put it here, that's at 71. See that? If I put it here, that height's at 66. So that's how I got it. Couldn't we use the T-chart? Okay. I hear you. I don't like that, but I know what you're saying. You're saying, I just look at this and go, look, since it's going up by 1 second, that's 4, that's 11, that's 22. Well, you got me. Yes. But here's why I don't like that. I'm not saying it won't work, but what if, like when you're plotting a curve, you're going to have some points that are not on the smooth curve. And I think this is mostly pretty good data. But suppose you had a point, a dot that was off the curve that you ignored when you did your smooth curve. And then you go through and do that business. Then you're going to throw you way off on that crazy dot. See what I'm saying? So you should go, once you have your curve drawn, you should erase your dots. Once you have that smooth curve, and if I'm smart, I'll put a goofy point on the test to see if you fall for that trap. Yeah. I'll probably forget, but anyway, that'd be kind of good. Put a couple of goofy points in there to see if you're really following a curve or if you're just going off this. See, that's like the lazy man's way. And you get away with it here because the points are all pretty decent. Schlager's still talking. How do you, okay, yeah. Because I know. Ryan said, couldn't we use the T-chart? Okay. You hear what I'm saying though, right? You guys hear what I'm saying. Yes, you can use the T-chart if you 100% trust every dot, which normally you can't do. Okay. Elizabeth's asking, how did you plot the velocity on 1? Oh man, 1's getting all the questions. Well, what I did was, okay, so I'm looking at steps. So like 0 to 1, that's going to be 4. I made it 4 or 5. So see my step right there, from 0 to 1 is about 4. 0 to 2, 1 to 2, my step is 14. So there's my next step, 14. So, I'm doing like we always have done it. You just plotting your step, you're plotting your little slopes, and you're seeing that the slopes of these yellow right triangles is increasing. It all stays 1, but the height's increasing every time. So that's what I'm plotting. I'm plotting these as the level of my steps. Okay. And then I collapse each step down to a dot. Oh, look. That one, that guy, that didn't. Look at that. See that one right there? It doesn't quite fit the trend. Yeah. So it looks like between 6 and 7, you get a goofy one. Jumps, look at that. It jumped up to 64. So you had to realize, and when I did my best fit line through my green dots, I kind of ignored that dot. I'm assuming the person that did this screwed up between the 6th and 7th second. Because nature paints with a broad brush. That's going to be a parabola, okay? It's not going to be some weird thing that has a bizarro equation. You don't get those macroscopically in nature. You might in quantum, but okay, Shargo says, but if we had already plotted the curve and found no funky dot, yeah, sure. I don't know what. Oh, I know why. I get it. I mean, we're having an argument, not argument, we're having a discussion about, I'm trying to speak conceptually that and calculus wise that I'm trying to get you to understand calculus. And you're going, well, look, I found an easy way to do it, but okay, it's a shortcut. Well, what if the times weren't all 0, 1, 2, 3, 4, 5, 6? What if it was, my first time was 1.1 second, then I checked it at 4.3 seconds, then I checked it at 5.2 seconds, and then I checked it at 6.7 seconds. See what I'm saying? Those essentially are looking at little, I mean, I don't know. Maybe I made it too convenient is what my point is. Maybe I should have messed it up a little bit so you couldn't do that on the T chart. The one of the tests will look a lot like this. I don't want to screw you up that bad. I'm not gonna go out just be vindictive and try and prove my point. But so maybe your question is, on the test, can I just go off the T chart? Do I need to? Maybe I don't notice. I don't know. But I do need to see. I will look. You go, well, if I can go off the T chart, why am I even plotting that? Because that's the exercise, but also that shows the position. See that little weird step right there? That little bump? Probably I should have ignored it. That's probably my bad. Right here, I probably should have ignored that a little bit because it messed up my parabola a little bit. Not that noticeable, but anyway, that's because between 6 and 7, the operator who was doing the lab screwed up. Human error. Oh, yeah. Okay, so Ryan's making my point. He said I used the chart and got 7.2, which was really off, and then he probably just ignored it. And Elizabeth said 7.5, which, okay, hey, then you come down here and you go, and I got to look, mine's off the best fit line. I agree, mine's off the best fit line too. So, but what did you get for the slope? I got 8.8 for my slope. What'd you get for your slope? Is that, oh, you're saying those are your slopes? Well, hold on, let me my slope. My slope, I said I run, I said I went over 5 seconds. And I said in 5 seconds, I ran 40, I rose 44. I ran 5, rose 44. And I got 8.8. That is correct, right? Yeah, that's it, 8.8. Because 45 would be 9, so 8.8. But you cannot argue. I mean, you look at look at this. There's nothing wrong with my best fit line. If I put 7.4 as my best fit line, I would be, let's see where that puts me. Go over 1074. That puts me way over here. What is this by fours? Yeah, so 64, 68. So that puts me, that puts my best fit line like over here, which isn't even close. Hold on. Blue? No, yeah, blue. Black. No, pink. So look, that's my best fit line. If I said that slope was 7.4, I missed all my green dots. You see, so I would count off. No, I don't want to do that. Chagar said he wants to show me, but we can show me tomorrow. Like the test isn't tomorrow anyway, so. But you have to show me that you're more right than I am. I don't think you are. Yeah. So Chagar, tomorrow though, I do want to see your stuff because I'm curious now. Okay. Good discussion. Who else has a question? This is the way, this is what I love about physics is you look at the data and go, well, I disagree. And that's how we don't start calling each other names and don't start waving the flag. I mean, we look at the data and go, well, you know, there is the truth. There is a truth. I happen to think I did it correctly, but maybe tomorrow Shargo proves me wrong, and I've been proved wrong before. I love it. Who else got a question? We don't talk about one, we can talk about any of these. We're doing overtime now, so. Anybody else want to discuss something? Something. World Series on? What's going on? Okay. Well, okay. See you tomorrow then. My wife wants me to, there's a movie we're trying to finish watching, so we got to go down to that. All right, I'm going to take off. I will stop recording. Appreciate you guys. You guys are the best. See you tomorrow. I'll record this. Stop recording.